We're back to do questions for the math review session 4. So we have our first question here. It reads, a local provider has developed the following formula for a diaper rash cream. And that diaper rash cream includes all of these ingredients for a total weight of 1,500 grams. Of course, we would compound that. The patient prescription is for 4 ounces of the cream. The question asks, how much hydrocortisone ointment in grams will be needed to fill the prescription? So remember, in our Uncle Charlie Sings, we have our unknown values and our known values. Our unknown is always what's being asked. So that is how much hydrocortisone ointment in grams. So that would be X in grams. Our known information will be given in the statement. We're going to end up having a setup in the end that represents a proportion relationship where we have a part per whole equal to a part per whole. That's the story we want to tell. If we have grams in ointment, that is a drug, which is a part. So we already have one top value of our equation here by having the unknown in X. Because it's asking about hydrocortisone, we actually do not need to focus on these ingredients for this particular problem because it's asking about how much hydrocortisone. So we have 454 grams that we're going to use of the hydrocortisone. That is a drug, so that would be another known value, which will be 454 grams. And then we also need our total volume. So that would be our 1,500 grams. So we only need one more whole. And that has to do, because it has to do with the prescription. This will obviously represents the prescription over here. The prescription is being asked here. How much hydrocortisone ointment will be needed? We need a whole amount. That whole amount would be 4 ounces. So we have all of our known values provided. Now, the next step in Uncle Charlie Sings is conversions. Do we need to convert anything? Because we have 4 ounces here, that's not going to work for us. We want that expressed in grams. Everything else is in grams. X will be in grams as well. We want to convert 4 ounces. We know that 1 ounce is equal to 30 grams. So if we know that 1 ounce is equal to 30 grams, we want to know how many will 4 ounces give us. So we would take 4 times 30, and we would get 120 grams. So we're going to change this into a 120 grams, and now we have all of the values that we need. So our setup is technically already right here, right? But let's just draw it again so it's nice and clean. We're going to do our setup here. So I usually set up my equation first. We do have the concentration already provided to us because the hydrocortisone in the problem says we're going to have 454 grams per the whole amount, which will be 1,500 grams. If I have grams on the left, I have grams on the right. Looks like I have grams for all of the values. We did our conversion, which was our whole amount, not our part, and that was 120 grams, and then our X should go at the top. Remember, the story that this equation tells should match what we're solving for and match the story that's being told in the question as well. So just to recap, to make it clear, we have 454 grams of hydrocortisone, which is stated here, per 1,500 grams, right, which is stated here. Why did we zone in only on the hydrocortisone? Because the question asks how much hydrocortisone ointment in grams. And because the question asks that, we know that our unknown value going to represent X in grams, meaning that represents hydrocortisone in grams, will be needed to fill the prescription. How much for the total prescription? 120 grams, because 4 ounces equal 120 grams, and we converted that, and that's here. The top represents part per whole, drug per volume or mass or weight. All right, drug per mass or weight. Now, that was the hard part. So once we have a setup, we know that we can now solve. And how do we solve? So we can just simply do cross multiplying, or we multiply across. I like to keep my x on the left, so I do 1500x. And then we multiply the top left by the bottom right. And we get, help me out here. Once we have this set up, we still want to solve for this x, so we want to isolate x, get x alone. How do we do that? We're going to divide this by 1500 so we can isolate x. Now we have x by ourselves. If we did that to this side, we have to do the same thing to this side. So when we got 54,480 divided by 1500, we get x is equal to 36.30. We get a fractional number. This is multiple choice, and it looks like our closest answer is going to be the 36 here. So that's our answer. Moving along. Question number 2. The question asks, the pharmacy stocks a 300 milliliter bottle of 7.5% solution. If the dose of the solution is 1 teaspoon, what is the drug dose? So this one seems simple enough. And yes, we can do a proportion equation. Let's start off with our unknown, because the unknown is always what's being asked. Our unknown is, what is the drug dose? So we're going to have X, our drug dose. I'm going to underline that. Drug dose is going to be X in grams. And then our known, that's always given in the problem. So our known is 300 milliliters. And then it's also 7.5%. Remember, every time we have a concentration or a percentage, this equates to 2 values, part per whole. So 7.5% is the same thing as 7.5 grams over 100 milliliters. That is considered our concentration. So we can convert that in our head or just make a note of that. We have one unknown value and 3 known. 1, 2, 3. Anytime we have a concentration or a percentage, it gives us 2 values. It summarizes that. So we branch that out so we can be very clear that we have all 3 things. Now, do we have to do any conversions? Remember, we want to make that an explicit step. That's our Charlie. That's our conversions. So it says if the dose of the solution is 1 teaspoon, that's actually not the dose. That's the volume. But the 1 teaspoon is going to deliver the dose. So we do want to do a conversion. So we want to do our conversion here by converting 1 teaspoon is equal to 5 mLs, because these are the units we ultimately want to use when we're giving the information to our patient. We don't want to say teaspoon. We want to tell them specifically how many milliliters. So we converted that. So now we can go right into our setup. And I did skip a few steps of the Uncle Charlie Sings methods, but I hope you are still following me. Remember, this story tells part per whole, so always remember that, so you make sure you set up properly. If you set up properly, then you're headed to the right answer. So you definitely want to make sure all these values are correct. That's the most important part, understanding the question and setting yourself up properly to arrive to the correct answer. Remember, our concentration is always given to us. There's no need to split that up. So 7.5 grams at the top per 100 milliliters at the bottom. Then we have 5 mLs because we converted that. We're no longer using teaspoons. 5 mLs work for us. That makes sense and is logical, because if we have milliliters over here, we should have the same units expressed over here. Also, a quick little cheat is if we have grams over here, we should have grams over here. So our X, remember, our unknown value is going to be X in grams. So now we have a proper setup. Of course, we can cross multiply and then solve for X. I like keeping my X on the left. So I'm going to cross multiply here and have 100x. Then I'm going to go 7.5 times 5. And I'm going to have 37.5. Then my next step will be to isolate x. So I'm going to divide both sides by 100. This will cancel out. And I would have x equals 0.375, right? And that is grams because we're solving for grams here. Do I have a match in my multiple choice? Let me read carefully. Let's not make a mistake. They tried to send us a curveball there. We have 0.375 grams here. Correct. All right, let's move along. I had a repeat question there, so we skipped that one. So now we're on this next question. It says, a pharmacy technician is asked to double check the mathematical calculations for preparing a 2.5 liters of a solution of 25% urea in sterile water for irrigation. The technician verifies that the amount of urea needed in grams is. Looks like we probably can use proportion equations. In order to see the criteria, we want to see 3 clearly known values with 1 unknown, and we want to look for that relationship of part per whole. My indicator is that there's a volume here given, which is a whole. There's a concentration given, which automatically gives me 2 pieces of information, 2 values. So that's already 3 known values. And then this whole, the question should be asking for the part. So if this is the volume, the question should be asking for the amount of drug, which it is, amount of urea needed in grams. So this kind of fits the storyline of a traditional proportions, and we can use that Uncle Charlie Sings method. So I'm going to quickly do that. I'm not going to explicitly do the USC, but we'll just identify those known and unknown values. Now, my next step is, do I want to explicitly check for any conversions? It looks like we may need to convert this here. Let's see, 2.5 liters. And the question is asking for everything in grams. If we didn't know to convert this 2.5 liters, then we would get something weird in our setup, and we can always convert in the end. I think I want to go ahead and make a note to convert this. So 2.5 liters is the same as 2,500 milliliters. So I just want to make a note of that and probably use milliliters. So now I want to go right into my setup, and I'm going to set my equation equal. Remember, part per whole, concentration is already given. So I'm going to plug that into my first side here, and I'm going to do 25 grams over 100 milliliters, because that represents my concentration. That is the same thing as 25%. Over here, this is going to be my whole, and I want to use milliliters because this is in milliliters. So at this step, I would have known I need to convert. But we've already acknowledged that, so we're going to go ahead and write that. So we're going to go 2,500 milliliters. That should leave me with an unknown value of X that we need to solve for. And X should be in grams because the question says in grams. So our setup is correct. We felt pretty confident that this represents the storyline of the question. So now we're going to solve for X. So first I want to cross multiply. So I'm going to go 100X. Then I am going to multiply the other side, and that's going to be, help me out somebody, 62. Now I want to solve for this X. So I want to isolate X. So we're going to divide both sides by 100. And that allows us to cross this out, and we get X is equal to, so let's see, 625 grams. So that is 625 grams. I hope I didn't cause confusion on that one. On to the next question. It looks like another proportion question. This one seems not too bad, though. A prescription orders 1,000,000 units of penicillin G. The penicillin G on hand is available as a solution. The solution is containing 250,000 units per milliliter. What volume of stock solution in milliliter is required? Let's see what we got here. So we can do Uncle Charlie's thing. This is definitely a proportion equation because we have 3 known values and an unknown. So unknown is going to be the X in milliliters of penicillin G. Our known is stated. It's here. That's the RX order, the prescription. Then we also have the concentration here. That's the concentration of the penicillin. The pen G concentration, which is 250,000 units per 1, because that's a 1 ml, 1 ml. So we do have all of our values here. We have 1 unknown and 1, 2, 3 known values. Let me make sure that's clear. That is 1, because we should have 2. I always say we should have 2, 2, and 3. This is 1. It's assumed 1, 2, and 3. Now, our next step that we explicitly take care of is our conversions, which is our Charlie. So I'm going to say we don't need it. If I'm wrong, I will catch it in my setup. Then our setup, which is the fun part, we're going to go right into setting up our equation. And this just tell the story of part per whole. Our concentration, we can always keep that as is. So we're going to go 250,000 units, I guess, over 1 ml. If I have units over here, I am having units over here. And then if I have milliliters over here, I am having milliliters over here as well. So then what are our other values? We have the units here. So that's going to be, if I have room, let's see, 1, 2, 3, 1, 2, 3. Made it work. And this should be our X value, right? This should be our X in milliliters, which matches here. This is the penicillin we're solving for, and it's the volume. All right. Now let's double check that this storyline makes sense. The storyline of our equation. We have the concentration over here, which represents part per whole. That represents what's here. So that checks out. Our concentration is usually pretty straightforward. And then this is our units. So this is going to be the dose, which is the part that goes on top. And then the whole is the volume. How much volume is used to deliver that dose. And this dose is in units. So don't let that throw you off, because we've been used to seeing it in milligrams or grams. Units, remember, is a dose as well. And we see that in our insulin questions. We're ready to rock and roll. So now we can solve for X. We're going to cross multiply first. So I'm going to come over here and have 250,000 X equals, and then we're going to cross multiply this side, was just by itself. So keep that a milli. Then we can divide both sides, and we're dividing it because we want to be able to cross this out and get X by itself. That is a 2. And we have X equals 4 milliliters. Remember to include your units because we are solving for X in milliliters. The question says, what volume of stock solution in milliliters? So that's correct, 4 milliliters. Our next question is how much hydrocortisone powder in grams is needed to compound 1 pound of 4% ointment. This is a one-liner. We cannot go wrong here. It's not a long, wordy sentence of a problem or multiple sentences. We can use a proportion as well. Our Uncle Charlie sayings. I'm going to try to do it kind of quick so we can kind of go through it in our head, but is asking for hydrocortisone powder in grams. So that will be our unknown value. And then it should give us 3 other clearly known values that follows that story of part per whole, showing that relationship. So remember, this will be our X in drug. And then our known, it looks like we have a known here. And then remember, anytime we have a percentage, that gives us 2 values. So we already kind of know. So let's just skip into our setup. I am skipping the conversion step, but we're going to acknowledge that in our head of 454 grams. So just make sure you remember to do your conversion step. So concentration, I'm always going to keep together. So 4 grams over 100 grams. That checks that. Then over here, I'm going to put the 454 grams at the bottom because that's the 1 pound. Then I'm going to do my X in grams here. Boom. All right. Then we can cross multiply. So we got boom, boom, 100x is equal to, what is it at? 18. All right. If I ever mess up any of my decimals or little values on these, I hope you all are not just watching, but you're checking your work and actually going through the steps yourselves as well, just in case, to make sure you understand. And then we're going to cross that out. And X is equal to 18.16 grams. And it looks like this checks out. We do have an option here. I believe this is the last math question for this session. The question asks, the final question, the quantity of sodium bicarbonate powder required to make a 50 milliliter of a 0.5 solution is. It's just kind of ironic how the questions got simpler. Should have started with the simpler ones first. So we can use a proportion as well. This is a one-liner, so I'm just going to jump right into an equation, and you can kind of mentally go through where the unknown is. That's our question, where the known values are, and the part per whole relationship. I'm going to do 0.5 at the top. This is our percentage over 100. That's actually grams over milliliters. And then I am solving for sodium bicarbonate powder. So I know that that is my X value in grams. And I know that my total amount is 50 ml that's provided in the question. I'm going to cross multiply and have 100x equal to 25. Divide both sides by 100 so I can isolate x. And then I will have x equals 0.25 grams. Yes. So let's just double check. So what we want to do to convert grams, remember when we convert grams to milligrams multiplied by 100, or move the decimal 3 places to the right, 3 times to the right. So that would be 250 milligrams. So that would be our answer. So this is correct. Hope this is helpful, and I will see you all in the next session.